You got it. That was a good one. You broke the glass, broke it, everything.
Right. Is it memorized? Here, you want this one?
Perfect. So no, thanks again for the time and the opportunity to be here with you folks the past day. And we'll also have presence at the Nth conference over the next few days as well. But goal today was to go a little bit through who Scality is, just a quick overview of the company. Obviously, we have a very strong alignment with HPE and a go-to-market with HPE. They are a key investor of our platform and our company. And from a go-to-market perspective, we're actually doing a lot of strategic alignment and initiatives, which we'll talk about as well. But high level, Scality was founded almost 10 years ago now, been in the market, recognized as a market leader in scale, file, and object. We have a little over 200 plus customers globally. And our headquarters is actually in San Francisco. We were founded in Paris, so that's actually where our founders came from. And kind of a little bit of history on the company is that we saw certainly a need to solve for scale-out file and scale-out unstructured use cases, right? We saw the emergence of webmail, content-driven applications, mobile, next-gen applications, et cetera. Billions and billions of objects, not necessarily within a location, but across geo. And that's really kind of how the company was really founded, was to really solve these big data challenges, right? But as you can see, is we're mainly focused in the Fortune 2000s. We certainly focus a little bit more upmarket, being a scale-out platform. We work cross-vertical, so we work in media and entertainment, service providers, large financial services, large manufacturing, large healthcare, life science, et cetera, and a multitude of different workloads, which we'll talk about. One of the unique things about our company is that when you look at Gartner and IDC, we're consistently in the top right-hand corner. And if you look at some of our key competitors, so EMC, we look at IBM, we look at Hitachi, look at NetApp. In Gartner, it's a little bit different landscape, as well as is that we actually attack this market with one platform and framework, whereas all the other folks that we kind of compete with, I guess you would say, in this space, do this with multiple products to attack that marketplace, right? So we'll talk a little bit about architecture and how we go to market in our build. And I think hopefully that'll paint that picture of how customers are leveraging us in the market. But we're essentially the only independently owned platform in this space, which I think is unique, especially in the top right-hand quadrant, right? So what do we look for? We're looking for customers with hundreds of terabytes, probably 200 terabytes and above. Unstructured data, this could be things such as images, files, scanned documents to user files, user content, content from devices and connected devices and IoT. And this is the kind of data that we're looking for. We'll kind of get into use cases and workloads, but unstructured data is really where we're focused. We are a software platform, right, that rides on HP Apollo hardware. And we actually have a turnkey appliance deployment method with HPE. So therefore, for customers, it's very programmatic and repeatable and scalable. And we actually protect data across geographies, right? So I think you guys are probably familiar with things like geo-erasure coding and things like that at scale. This is exactly what the public cloud providers are doing at scale to keep low overhead, but keep high durability and availability methodologies, right? So we're bringing that to enterprise customers and service providers at scale to provide those, one, SLAs, and two, the low cost to serve that really the market requires, right? So again, unstructured content on HP hardware, turnkey, appliance-like experience at web scale. So if you look at the market, here's the unique thing is that we look at customers is that about 80% of, when we walk into an account, 80% of the day is unstructured, right? Could be on Windows, could be on filers, could be what have you, is that about 80% of that content is unstructured and it's growing at a rapid pace. So if you talk to a lot of customers, they're growing 50% year over year. Some are more, some are a little bit less, right? The unique thing is that when you look at the profile is about 50% of that data is actually created outside the data center, which is a unique difference over the past few years. But more importantly is they have this big digital transformation wave that is growing 10x what their traditional workloads are growing at, right? Those have a much different appetite for infrastructure than traditional workloads, right? is that when we look at it from a customer perspective, is that we look at ourselves as a bridge technology. We can work in traditional workloads, which we'll talk about from a use case perspective, but having programmatic interfaces and a flat namespace for developers to consume at web scale across geos in an active manner is exactly what those next-gen applications require. And we'll talk about how we power both traditional workloads, but also provide that platform for the app architects, enterprise architects, developers to drive those next-gen in digital transformation projects within the enterprise. Not to make this even more complex, but multi-cloud is real, right? So if you see the quote here from Andy Jassy from AWS, the CEO of AWS, is that when you look at customers, 85% of customers have a multi-cloud strategy, meaning they're not going to ride with one cloud vendor, they're going to have multiple, right? So I might have some workloads at Azure, I might have some workloads on-premise, I might have some workloads at AWS, or some at Google, but I'm basically not going to put all my eggs in one basket, and there's a multitude of reasons for that. 9% have a single public cloud strategy, 5% have a single private cloud strategy, right? And 1% have no plans, right? So when you look at it, when we talk to enterprises, is that we've got this multitude of workload, massive scale, most of it's on-premise, this workload over here that has a different appetite for infrastructure, traditional workloads are growing, and then the business is also saying, well, where do I want these workloads to live, and why, and how, right? That just adds another dynamic to the customer pain point and challenge, right? And our approach is pretty simple, is that one is we want to have a common design principle, really based on 4 major criteria, right? One is we want to develop a common platform or utility, right? Is if you look at all the public cloud vendors, is that they've got pillar services and then microservices run on top. Is that we want to give customers a platform that hosts multitude of different use cases, right? Host many use cases on a single platform, eliminate traditional silos that they might have today with particular boxes, platforms, networks, locations, et cetera, right? What everybody was building one-off configurations for applications is that building a common utility is really a strategic way for us to get alignment, right? And help customers through these challenges. 2 is single point of management, is that customers have multitude of different points of management. You have to manage that skill set. It's very tough, and to do that at scale with those ramp rates that we saw before is very difficult. So having a common methodology for managing a service is critical, right? 3 is leverage multi-tenancy, right? Everybody, when you look at a lot of the enterprises today, they've got purpose-built boxes in single tenant and physical isolation, is that when you go across that, it's really tough to get high rates of utilization when everybody's got their own purpose-built device, right? Is that I've got the finance team that has a requirement for capacity or performance. I have it over here, but I can't map these resources because of traditional architecture barriers, right? And we want to break down those barriers. And by doing that, and provide secure logical isolation based on policy that is secure, and then provide things like metering or showback or chargeback based on usage, not what I purchased or what I have provisioned or allocated, is critical at scale. And I think there's a major cost benefit to doing business that way. And last is that if I can do things in this type of manner and transition a lot of those manual tasks, rate sets, snapshots, replication, failover, failback, backup, recovery, and I can automate a lot of those things that traditional people have to do hands on keyboards, there's a ton of benefit to that. So I can get an FTE ratio from maybe 1 FTE to a few petabytes to maybe in an object world or a scale-out world, we're seeing 1 FTE to 50, 100 petabytes or even more, right? And I think that's ultimately the key. We want to build standards versus one-off, and then we want to use things like geoprotection to reduce overhead, right? So if you look at what we're doing with 3 and 4 site configuration, 1 gig can consume either 1.7 or 1.5 full site durability or within site durability as well, right? So I can get site durability by rating across sites or erasure coding across sites, and I might be able to reduce my storage overhead by 50% over traditional because I have One copy, I replicate to site 2, and I've got RAID overhead at both. And then I've got things like snapshots overheads as well, right? Plus, I'm probably backing that up, right? And we'll kind of talk about some of those principles, but the whole notion of geo-protection and the overhead reduction is a major one for companies, right? So really what we're looking at is object as a service, or scale out file and object as a service, is that we want to host a number of different workloads on our platform. Number one is we want to look at long-term retention for backup and recovery. So, there's a lot of platforms. You get store once with HP. That's usually the first 30 days or 60 days, the high performance backup, but the long-term vault copy, right? Where potentially tape would be your weekly fulls, your month ends, your quarter ends, your year ends, is that a lot of people are leveraging object storage because those applications up top can, one, write natively to our platform, either through file or through object API, but many of them actually have built-in dedupe capability, right? So that's number one, is dedupe plus that low overhead for multi-site protection has a great return on investment. I don't have to do things like tape tech refresh every 5 years. I don't have to worry about multiple copies of the same tape set. What if I want to delete, a certain piece of information? I can do that off of disk, and obviously disk has erasure coding protection, right? Protects against things like bit rot over time and other things, right? Messaging and collaboration. So we're seeing a lot of success with remote office, branch office, user and department share use cases where we're leveraging front-end applications like cloud gateways or enterprise file sync and share like Satera, which I know has a relationship with HPE. We work with Panzura, Nasuni, and others in that space, but we also work in a very unique workload for webmail. So like if you guys are familiar with like Open Exchange or Zimbra, or those types of web platforms, is that we have a very unique capability, and I think it's one of the things I really haven't seen with a lot of our competitors, is that we own about 80+% of the webmail market lives on our platform as a primary repository. Because each one of those messages they're a file, right? And they just leverage our RESTful-based API. We work active across multiple sites, billions and billions of objects, thousands or even tens of thousands of concurrent connections. Is that a scale-out platform is really fantastic for that type of workload. So we have customers like Rackspace, Comcast, and others, Orange, that are leveraging us for their webmail platform. Or if you have a Comcast account for cable service and you get a mailbox with them, that's actually riding on our platform, right? And the reason why is because we're a complete flat namespace that we don't have a lot of the traditional challenges that traditional storage has around limitations of file count and size, et cetera, and scale. Archiving is certainly a huge play for us. We do a lot with file archiving, email, SharePoint, database, et cetera. And we have a number of ISVs that help us in that area, where the primary landing point today might be a Windows file server, it could be a NetApp filer, it could be an Isilon cluster, could be a Cumulo system, doesn't really matter. We work with a lot of the vendors that will leave a stub or a link, move it to the object store transparently, no change to the ultimate end user or the application. Very simple, but the main benefit is, if it hasn't been accessed or modified in 6 months or more, one, do I want it on an expensive tier 1 disk? And then two, I take it out of the backup cycle. So you can really reduce your backup and recovery time and the amount of content that you're actually writing daily by just archiving, right? And I think that's a huge advantage that a lot of customers are looking at today, and we do assessments on those as well. So we can look at a file system and say, 70% of the data hasn't been accessed in 1 year or more. We could tear that down transparently. Now my backup is 50% less, right? There's a major TCO with archive, and it's a major play for us. And then really the two plays on the right are the ones that are emerging. We work a lot with app architects, developers, lines of business, is next-gen web applications, mobile applications. They're looking for a native RESTful-based API, very programmatic experience to do, puts, gets, creates, reads, updates, deletes, and they're also using our metadata search capability to manage content at scale. Is that a RESTful-based API is very simple for app architects and developers to really scale these applications or these distributed web applications at scale. And then lastly is that when I have all this data here, is that adding additional services around big data intelligence is critical, right? So if we can provide access to my distro of choice, the data's already here. All I'm doing is moving my compute to the data versus moving data to compute. I think that's always been the challenge with big data use cases, is that I've got this mountain of content. If I have to ETL it to another system with nodes and DAS, it's a lot easier just to do it right off the source, right? And I think that's what we're finding is, okay, once I get all the content in, is that providing access to my distribution of choice globally allows me to be very elastic on how and where I borrow compute resources to do those analytic workloads. They can be anywhere. They hit that flat system namespace, and they're gonna get routed to the system that's closest to that particular request. Now, as you can see, is we've got multi-site geoprotection, but I also have public clouds there. So one of the things that we're really focused on moving forward is not to be just a private cloud scale-out file and object system, but we've actually launched a platform called Zenko, which we'll talk about in a minute, is that essentially take the namespace off the storage system and put it a layer above into the network, and then allow for third-party storage, and we'll talk about that, as well as public cloud tenants like AWS, Azure, Google, Alibaba, and others under the same flat namespace, and leverage our multi-cloud controller to manage where data gets distributed based on policy. But to the app architects on the right-hand side that are building these next-gen web applications, whether it's these packaged applications for messaging, collaboration, backup, archive, they're reading and writing from a same flat namespace, and I can have public cloud tenants under that same flat namespace, one system. Same metadata, same API, flat namespace. We believe that having that abstraction and giving customers control now is, we'll just say this, I've got a copy within my private data center, and then I've got a copy in Google and a copy in AWS. And we'll just say Azure comes in and gives us a great deal because we're redoing our ELA. I can do a delete out of AWS and do a put into Azure. I've got no egress. I don't have to worry about API compatibility or policy control if there's any life cycle or GDPR or anything like that that needs to be adhered to. It's all done at the abstraction layer, which the customer owns, right? We think that that's extremely powerful, right? Now, as customers have freedom, choice, and control of how their data is written, where it's written to, why it's written there, but not have to change anything from an access perspective up to the application owner or the user, which I think is really unique. And this is something that really Scality, coming to market with this type of technology is really a game changer. And we don't see anybody else in the market really executing that. So some of the things that we've realized in the field with HPE is certainly just drastic reduction in storage operation costs, great return on investment. You know, most customers are seeing a return within 9 months, which is fantastic. Total cost of storage being decreased because we're using lower cost, dense hardware based on Apollo. I think that's obviously a good thing. Efficiency is really critical. So when we go from manual to automated, those things really help out with total cost to serve. And then some of the things that we look at from a principles perspective is erasure code is based on protecting the data, not the hardware. So when you're taking data and erasure coding across disparate nodes and drives, you've got all the hooks into the hardware with HPE. So we know that, you know, there's an issue with this memory or this disk. I'm going to redistribute, so I'm protecting the data. And then I do my policy control based on the data profile, not of a volume or whatever. I have bucket policy with SLA based on whatever your end user needs. Is that we're seeing, you know, one, unplanned downtime is majorly reduced because you have fine-grained control of how you erasure code across local and distributed sites to get to whatever SLA you want. And to give you an example, we've got a joint service provider in Europe, and they've been running for 10 years, never been down. We've done 4 hardware tech refreshes, and they do hot fixes and everything. It's all rolling upgrades, completely transparent. I mean, talk to a lot of other, you know, key storage players that, you know, you folks probably are accustomed to working with, is migrations are a pain, platform to platform. There's usually an interruption. Even adding bug fixes or hot fixes or dot releases or major releases, there's downtime associated with that. We don't. We do those rolling. Everything's always on. And I think we have some really great examples of that in the field. So why Scality and HPE? And I swear this is the last of like the salesy stuff before we get into the cool architecture stuff. Number one is we could provide a turnkey offering for storage as a service. I think that's critical. We know multi-cloud's real. We know multi-cloud's happening. Customers are figuring out their transformation journey now. Is that we can give them a turnkey platform that allows them to make that decision and allows them that control in a turnkey offering. That's not a box of Legos. It's a very programmatic and efficient way to deploy. And we've got reference architectures and customers at tens of petabytes of scale that we can look towards, right? Two is we've got a ton of ISVs that we support. I think this is critical, not necessarily for the next gen use cases, which I think is certainly emerging, but backup applications, archive, content management applications. If you're in healthcare or media, the MAM-DAM applications is having those integrated hooks into those applications makes adoption of our technology completely transparent and easy and programmatic, right? Eliminates a lot of the risk. So we've done the performance testing, we've done the scale and failure testing to make sure that customers have a very predictable experience when they deploy in production. We are software defined on HPE servers, right? And I think this one to me is probably the most important is when HPE comes out with new technology at the server level, whether it's CPU, memory, if it's a new drive, is that we can take advantage of it. And when you look at it from some of the appliance offerings and some of the platforms that are out in the field is, they've got a form factor that you have to follow. We don't. You can add as little as 2 drives to a host, and those drives go into your cloud system. You can have different model of Apollo servers in the same system. We don't care. It doesn't matter. And I think the other thing too is we can scale based on the requirements. So we can scale for performance and capacity independently. So we'll just say if I have a form factor that's 15 drives and I got 6 of those, and we'll say for whatever reason I need more performance, so I need more CPU and memory. I can add CPU and memory either in a VM or a container in existing hosts that I have. I can also do that across anything that I have that's x86 in the environment. I don't have to keep adding the same 15 node block to get performance and then have a bunch of wasted capacity behind it. So you can scale what we call connectors independent of capacity. And when we get to like cost to serve and our goal is we want to run 70+% utilized. I mean, that's what a lot of customers want to do. Is that if you look at a lot of customers today, they're running at 20 to 25% utilized. So every buck they spend on storage, they're basically throwing away almost, could be 70 to 80 cents of that. We want to realize utilization, which drives down cost. And one way to do that is that if you give customers an ability to turn the knobs and dials is if I can add performance for CPU and memory, independent of capacity, that allows them to tune the system based on their workload demand, which means that allows them to not have stranded capacity and to drive down cost, right? And then multi-cloud. Multi-cloud is big. A lot of people are making platform decisions right now based on a year or 2 or 3 or 4 years down the road. Okay, I'm going to use you for private cloud today because that's my immediate challenge. We know multi-cloud and hybrid cloud are coming. So if you support those things natively in the platform and in the offering through the partnership, then obviously that's a unique one. And I can honestly say, if you look at a lot of the other folks that we see in the market, I'm not sure that that's really a core focus, right? And I think for us, it certainly is. So we'll get a little bit into the architecture, but from a platform perspective, is that we've got 2 products that we brought to market. One is, I don't know why it keeps doing that, but that's not good, right? So we've got Ring, and that's our private object store. And then we also have Zenko, which is our multi-cloud controller. And we're going to talk a little bit about those right now. Is that from a Ring perspective, Ring is really based, again, software defined. We support native objects, so S3, and then we have a low-level S3 or a RESTful interface. We've got native file capability, so you can do NFS and SMB, right? And then we also have a single UI management. So again, is where scale out any to any, shared nothing, self-healing, globally distributed or issue-coded platform, and you basically have an ability to choose what access method you would like for your storage service, right? So going to the UI, I could say I want SMB, I want NFS, and then I can have policies based on availability, durability, et cetera, based on those storage services, right? And again, this is on the same physical hardware and same platform, so there's not a separate NFS system or an SMB system, and there isn't a separate object system. So from an architecture perspective, it's 100% the same platform. Again, it's 100% software. And again, as we work across x86 servers, so the minimum we look at is 3 to start. And we can go to hundreds and thousands, and there's no limitation in terms of scalability with us, right? Because we're designed to kind of go in that fashion. So if you look at it, minimum of 3 servers, we can do distributed file and object, and then we'd have 1 VM as your management console. Pretty simple. From a protection perspective, we look at a couple of different things. One, I can replicate data. So some customers want replicas, right? I was at a large financial in New York last week. They're looking at us for a 4-site active backend to their loan processing application. And they want synchronous 4-site active. So when I write in one site, it's immediately available everywhere else. And for them, that meets their requirement, right? A lot of people think that might be overkill. But the reason is that, one, they don't, for them, it's a revenue generating application. 2, is that the fear of losing is actually, or the expectation of data loss is one thing that is a big risk for the business. So again, is you have the ability to choose how many replicas I want, local or remote, one to many, et cetera. And that's done in the policy engine. We do erasure coding, again, both local and across sites. And a lot of customers are doing this across 3 sites, 4 sites, et cetera, because they want that low overhead. So in a 3-site configuration, again, is my multiplier is 1.7. So a gig comes in, I take 1.7 across 3 sites. I can lose one of the 3 sites, or I can have a double fault within a site with no downtime or data loss, right? In a lot of cases, that's what we're seeing. A lot of people are doing that. Geo erasure coding is very popular. And again, we can do these in multi-site configurations. So if you look at it, how replication works is that if I've got a 50K file comes in from the application, I've got the connector, which could be designated S3, it could be designated SMB or NFS, it's up to you. The protection is done across every API that we support. It's all the same methodology, right? Is I've got a copy on one node, a copy on another node, and a copy on another node, right? So therefore, we ensure that there's no single point of failure. The data is placed across the disparate hardware, and that we're not putting 2 copies on the same node, et cetera. Therefore, if I lose that node, I lose 2 copies, right? So we manage the distribution of that and the balancing of the hardware. From a erasure code perspective, this is basically an example. Again, a 50K file comes in through the connector. As you can see, is what we do is we create 9 data bits and 3 parity bits. Pretty simple. And then what we do is, again, we distribute them across the disparate nodes and drives appropriately. So therefore, we manage that fault domain, right? And these nodes could be within the same site, or they could be across sites. That's how you can configure your cloud. Those are some of the configuration guidelines and thoughts, is that you have an ability to do this type of parity scheme across either a site or across many sites, right? So I can actually erase your code across, I can do a 9+3 across 3 sites. And those nodes can be anywhere as long as they've got network access. So if you look at some of the deployments for most customers is that we have customers with a single ring or multiple rings or stretched rings. So a ring actually could be, I've got like a geo, like within synchronous distance. I could have multiple sites and nodes distributed across there. I could have multiple rings that have physical isolation, where you might in the larger enterprises want to isolate particular hardware from another and have, you know, it could be for security reasons, it could be for business reasons or locality reasons. It's really up to you. As well as I can have, you know, single rings basically federated together and create stretch systems, right? That can span cross-region, globally, et cetera, in a global enterprise, right? So let's talk a little bit about the connectors, okay? So scale-out file, we support SMB3. And NFS v3, we're going to be supporting v4 closer to the end of the year. Haven't had a ton of requests for v4 yet, but you know, that's something that's within our engineering team right now to support. Some of the unique things that I think are really great about our file system, number one, it's stateless, which is, you know, if you talk to customers today, like managing inodes, and then, you know, an application mounts a node, is that you sometimes could get hot nodes. Even if you're doing DNS round robin or what have you, is that I create a persistent connection to a node, even in a scale-out system, is that we have a built-in load balancer to make sure that I'm not going to overload or overwork one node versus another node. So at scale, especially with these content-driven applications, that has been a huge game changer. So like in financial services, in life science, in healthcare, and media, big time in media, because a lot of those workloads are still really file system driven, is that having that stateless capability is critical. We don't have an issue in terms of amount of volumes in files in our file system. Again, is we're providing a connector on top of a distributed object store. So you don't have to worry about file count, directory limitations, et cetera, like you do in a traditional NAS environment, which is great. So we have a distributed metadata repository for POSIX. So one of the things with Scality is that we do support metadata search, right? So we do have that. So you can tag objects that goes into our database. You can query it, and you know, at scale. If you think about it, one is we're seeing that as being unique. Is that if I have a file application today, then I'm say maybe going from monolith to microservice. Is that, you know, I could resolve a GET command through S3 based on the, you know, the name of the file, the POSIX information, right? So it makes that transformation easy. But two, if you got to do things like lists and things like that, it's much cleaner to do off a database than it is off running through a directory, hence why we don't have a lot of the limitations that we see with traditional file systems. But metadata, to me, I think is a key service that we have native, is that we're finding a lot of customers using metadata for a multitude of different workloads. One is it's the transformation side of the house. And then two, it's I might have other applications that need access to that unstructured data for different reasons, big data or something else, right? Where maybe I've got an application that's in-house that I need to put a portal on top of to share certain data outside the firewall for B2B and B2C use cases, right? So metadata to us is really critical service that we supply. And again, it works on S3 and also works on the file side of the house. And we also do things like file versioning. We can enforce quotas. And things like that a lot of our enterprise customers have asked for, as well as Worm. You know, we see Worm a ton, obviously, especially with financial services and media and healthcare, et cetera. Worm is more and more of a requirement. So with our S3 connector, again, I think we mentioned this before, is both the file and with the S3 connector is it can live on the physical node of the storage, or I can scale those connectors across any other x86 server that you have in the environment as a VM or a container to therefore really drive performance if that's required. So it makes it very, very simple. But we also support things like S3 metadata. We use the S3 API for utilization, which is a standard on our platform. So therefore, when you want to do show or chargeback, et cetera, that API is native to our platform. We can do things like bucket encryption. We can do versioning. Obviously, we do Worm. And we can also do things like policy based on GDPR, right? I create a bucket. Anything created in France stays in France. It doesn't get replicated everywhere else, right? And I can also do that at a bucket level or at a ring level or at a tenant level, is that I have the ultimate control to set those parameters based on what the business requires, right? So therefore, if data that's created within a particular reason can't leave, or it can based on that, is that those can be defined services, again, automated through the portal, so therefore to make it extremely programmatic. And you can also do things around retention and bucket lifecycle management. We keep this for 7 years and then garbage collect it, delete it. So those are things that are obviously, native for us as well, right? So any questions? I know we kind of went through a bit. Make sense? Yep.
So typically people use replication when they need performance, and they use erasure coding when they don't want to pay a lot of money for capacity. So
Yep.
where do you draw the line? What do you tell customers?
So erasure coding, if you're within synchronous distances, you can get performance. As long as you don't have the tens of milliseconds latency, I think that's really the key, right? Is like I've got one customer that wants to have one namespace, Virginia, Utah, and then California. And then the longest link is like 50 or 60 milliseconds. So the thing is that you're right, is if I have to erasure code across all 3 sites, I have to wait for the ACK to come back from all 3 sites so I can confirm the write. So depending on geographic network, is that you're right, replica can give you the performance because I can get the ACK immediately locally, and then I can do an async distribution of erasure code to get your overhead. So there's things that we can do from a policy perspective to make sure that 1, you hit your performance requirement, and then 2 is if you wanted to do things asynchronously, like a distributed erasure code after the fact of the ACK, then we can also do that as well. So we do have configurations that that can do that, right? But that's a critical one, right? Is depending on like these highly transactional, like billions of tiny file workloads, like you want to have that, you need that low latency in ACK immediately to make sure you maintain performance. That's why we have the ability to do replica as well as erasure code. And then you can do things where you do it asynchronously. So therefore, these are things that we get into our stretched environment, because I might have an application that's writing within a location, and then I'm using replica to get the ACK, but the other sites need access to that as well, or I want to do something with site durability. So you can do that in a synchronous mode, whether it's multiple writes on the ACK, or you can do things asynchronously as well. So you do have some choice on how you do those, but you're 100% right. And I think the thing that makes that even more challenging is that with traditional monolith apps, those writes are typically coming from one site. What we're seeing now is that app is now looking to be like multi-site writer. So how do you do that and keep a common repository across all the sites? Which was my financial services example before, that was a monolith app, lived in a data center, replicated to site 2, and it was the standby. Just waiting for the fail. They've basically taken that and made it into a distributed app, and they wanted to triple or quadruple their volume. But now is how do I keep the storage namespace and all the content in sync? So therefore, when a write comes in site 1, how does all the other sites happen? Is we're using replica in a stretched ring environment to do that. But no, it's a good point. But those are the considerations you really need to make in a distributed system. Mm-hmm. Any other questions? Okay. So this is a little bit on Zenko. So I think I mentioned Zenko is our new platform. It's our multi-cloud controller. We actually just GA'd it 3 weeks ago. So you guys may have seen some publicity about that. However, this product's been running in a handful of customers for the past year, and we're taking it to market now. But essentially, what Zenko really is we can provide a unified interface, right? It's all container driven. This provides your SMB NFS as well as S3 access layer, right? Got it. we do policy-based data management, meaning, based on either the data itself, metadata, or at the bucket level, is data can be distributed, copied, erasure coded based on policy. And whatever the service level of the administrator wants to roll out, you have full autonomy to do that. When we do make those commits or writes into public cloud tenants like GCP, Azure, AWS, we make it in their native format, meaning we might give you an S3, but we're going to write it in the Azure blob. And we do not change the format of the file or the object. The reason is that if you wanted to do out-of-band access to that using a native, call it Azure microservice against Azure blob, we support the out-of-band interrogation of that information. We want to foster public cloud adoption. We don't want to be a deterrent from it. We don't always need to be in the data path. And I think writing in native format, when you hear customers talk about lock-in and other things, is like, well, when we write in those in that way, in theory, you could potentially move our abstraction out, not that we'd want you to, but we don't want to have the handcuffs on customers from a decision perspective. Common metadata and search capability. So you have common metadata across all your cloud tenants. It's actually built into Mongo. You have full search capability, which is fantastic. You know where the data is and what it is. And again, it's complete unification across all clouds. So if you look at it from a deployment method perspective, it's, I have my connectors here. I've got my Zenko abstraction, right? And I've got all these different cloud targets behind here, and it looks like one system, right? So I create a namespace, www.content.hpe.com, whatever my namespace is. I create services underneath. I register them through Zenko. I set up my policies based on whatever I think is appropriate, and the data gets distributed across those clouds based on policy, and we give a common access methodology, common namespace, common interfaces for access, data stored in the native format. And obviously, the reason is so you can use those external services if you like. And again, it's just high level on the capabilities. We do have NFS SMB, AWS S3 API today. Those are the native APIs from that controller stack, right? We obviously support Ring as one of those tenants. So Scality Ring is our private scalar file and object platform, lives in the data center, software defined on Apollo servers, right? So that can be under, it could be a tenant under that namespace technology, that controller, okay? One of the things we're working on now, we've actually already done this with Ceph, is that we're certifying all the other major vendors in the space. Meaning you could go into an enterprise and say, you've got CleverSafe, you've got EMC, you've got NetApp. I'm going to unify it with our namespace, pull it up into it, and then therefore I've taken down all the physical barriers and walls of managing systems, is that now I've created one system across physical isolated boxes, if you would, right? And now is if I want to go from vendor A to vendor B, you own the metadata, you own the access layer. You can take out vendor A and then go from Ceph to CleverSafe to Ring. Users, apps don't change, right? Or I can go from NetApp and maybe get rid of NetApp and go to public cloud and move it there, but to the users and the application, the access layer doesn't change, right? We think that that's a really important use case moving forward, is supporting that. But we also support Azure Blob today. We support GCP. We support DigitalOcean, Wasabi, and we're going to support others as they come. But our goal is to be that common abstraction for customers for on-prem storage and public cloud with a common API and a common metadata service, right? And we can do things like one-to-one replication, one-to-many. So to your point, I do the ACK locally. I do 4 copies to other cloud targets. We'll manage all those types of policy at a bucket level and at an object level if you'd like. Again, metadata can be user-defined or system-defined, right? This is where the developers are getting really strategic with how they tag. When they do their puts, they can tag metadata into our database, so therefore, derive value from that later, right? And again, we've got a single UI to manage all these systems and services, right? And we've got two really deployment methodologies here. We've open sourced this, so if you guys want to go grab it and look at it and use it, we do have that out in the community. You can go grab it off GitHub. And then we have an enterprise version, which is subscription based. That comes with full enterprise level 7x24 support that you would expect, deployed by Scality. And again, you've got the full stack in terms of using. Obviously, the community edition is really not meant for production, essentially, right? But you can certainly go consume it from there. But if you look at it this way, I might have Zenko on premise, and it's managing my ring system here, and then I've got multiple cloud targets back here. That could be a deployment methodology, right? Where we see this as being a use case is that I might just have one data center, or I want to get down to one data center, so I've got one ring. Maybe I want DR in the cloud. So I don't have to go buy a second Scality box or a Scality system. The cloud could be my pair, so therefore I could have I've got copy one here, and then copy two is in my cloud, and the controller manages that workflow. And we're seeing a lot of enterprises saying, hey, we're trying to reduce the number of data centers we have. We're trying to reduce our footprint. This cost to it is, well, maybe if cloud becomes DR, that's maybe my first kind of deployment into multi-cloud or hybrid cloud use cases is as DR, right? And we think that that's certainly the one that we're seeing a lot of traction with right now. The other one is that when we deploy in cloud, this one's a bit specialized, and we're seeing this with certain use cases, like in media, for instance, where I may want to copy in AWS and a copy in Google, and I want to basically manage my availability zones and regions against each other for a service level, or it's just at a control perspective. So I'm 100% public cloud, and then the customer owns the metadata and the abstraction on top of those clouds. So therefore, hey, AWS is strong in the States, but I've got a tenant in Australia, and the local provider there is, maybe Google's stronger there, or somebody else is stronger there. Is that there's going to be decisions, whether it's region-based, maybe it's a microservices-based, et cetera, is that we still see Zenko as being used in a straight public cloud use case, and we're designed to be able to deploy in that way, right? And again, is that, for us is that if I've got multiple rings and I've got, distributed systems, is that, again, we don't necessarily care, right? We can own that common management layer, and you can put essentially anything you want underneath. Could be our storage, it could be public cloud, et cetera. It could be asynchronous, it could be synchronous. It's really in and out of band. It's really what you want it to be. And I think that's ultimately our mantra, was to give customers control and choice with how and where they deploy their content, right? And some of the use cases that we look at are multi-site content distribution. We have this running at a large media company out of New York right now, where they're basically synchronizing on-premise with two public clouds. So it's actually AWS and it's GCP. So therefore, content's being distributed across all those and being created across all those, and we're keeping all that content in sync. So we see that as a good one. DR and HA, I think, is a very logical one, where we're seeing just a lot of interest, where I've got my primary data centers on premise, and then maybe I could put copy to public cloud, and that becomes my DR and HA. So therefore, I've got all this wasted gear on premise waiting for a failure. Why don't I rent the failure, right? So if you can move my data there, then I can spin up compute when I need it if I have a situation. So we're certainly seeing a lot with that. Edge to core to cloud, right, goes back to the previous presentation is if I've got all these connected devices, I could write it to this namespace, and then I could move it to either a data center or cloud or both very programmatically, right? Is that we're seeing that big data use case and connected device and IoT being a major one. And then given that we're barely building Zenko into the network layer, is that this allows a lot of these use cases at global at scale to have choice on how and where they write data based on policy, right? But those are just some of the things that we're seeing at a high level. But any questions or thoughts? Yep.
Metadata updates, I mean, potentially, especially like in that multi-writer scenario that you outlined, metadata updates crush a lot of systems. I mean,
Sure.
Isilon freaking dies.
Absolutely.
So how is your metadata workflow structured so it doesn't happen to Scality?
Good question. So there's really two components to that. One is there's a consistency factor, right? Is that when I write in, how do all the other sites know that you made data if it hasn't propagated, right? So that's number one. That's what I would call that's really system metadata. And the other one is that when I do create custom tags, is that if I tag something, water bottle, 8 ounces or whatever those unique identifiers are, how do I do a search and make sure that I capture all of that, right? So first one is that from a consistency perspective, think of it this way: is every node and site has a key range, right? So if I write something in site 1 and I'm at site 4 and I'm doing a stretch ring where I'm distributing asynchronously, and I say I need object 1, 2, 3, 4, I know based on the key range that it's created at site 1. It's going to go to site 1 and say, do you have this? Has this been created? Yes or no? And then it will resolve or prioritize the get. So that's kind of, you have a choice. It's either you're going to do eventual consistency or you're going to do strong, right? And that's a way that with a distributed metadata database is that you're going to have multiple site writers coming in. And then basically the ring architecture assigns ranges to sites and nodes to know where to ask for that. Hey, I don't have it yet, but I'm going to go get it. And if you get, hey, this doesn't exist, then that's another problem. That means the act never went to the application, right? So that's kind of how you do your consistency. You always go back to the owner who owns the lock, right? Whoever owns the lock is the person that owns the key. And we know, based on location nodes, where those ranges or values are. So therefore, when we get a request, it's just going to randomly go to a node based on locality and workload, right? What's available. And it's going to say, okay, this is what I need. I know that those bits should be here. So I'm going to go to that node and ask for it. And so that's how we do that. Second part is that we actually built our metadata store based on a distributed database. So we actually use, for search, it's Mongo. So therefore, anybody that's built out of MongoDB, distributed, is that we follow those same principles, right? Is that if I'm tagging data, and from a configuration perspective, I'm basically going to have a similar principle where I'm going to have an ability to distribute and architect my database across site to make sure that I have that consistency model. So therefore, is when I run my query, again, I'm going to make sure that all the metadata inputs are there, and if they're not there, I know where to find them and ask for them, right? In a distributed world, because you're right, the backbone, like nobody's faster than the network, and there's no free lunch and all those other things, is that you have to make design consideration. But since we're a shared nothing architecture and we're built on a distributed database technology, not only for search, but for the system metadata, which actually is built on Cassandra, is that we've built for those eventual and strong situations to, one, understand that, I'm not going to have an issue where I'm going to ask for something that's created, we just don't connect the dots. The system is designed to connect the dots, even if the data hasn't propagated. And then secondly is, if we're going to run queries again, I'm going to make sure that I have those inputs in a consistency model that meets that requirement, right? So therefore, it's aware of those distributed components of that application, if that makes sense. Where that's actually even more relevant if you lost a site. So what's the behavior of the system? We're going to continue to read and write and then resynchronize when those links are back too, which is another unique thing, is like how you set up your failure domains and communications as well is another critical component, because if you're working on a strongly consistent mode and if you lose a link, your decision may be to not accept writes because if you're worried about consistency, or maybe you do want to and then have them resynchronize when the links are back. Those are all design principles that we allow customers to design based on their expectation, not the system does X, work within X. We're very flexible on how you design that. If that makes sense. Any other questions? Yeah, I'm between us and exactly. But
if you deploy the open source version, can you guys upgrade it to the?
Yep. Yeah, we can give you a perm key. And just for clarity's sake, because I get this question a lot too, is I have Ring today, and I want Zenko. We don't charge. So if I've got a petabyte of Scality, you get a petabyte of Zenko for free. Now, if I want to start putting data in public clouds, I have to pay for the per terabyte subscription to put data in other cloud targets. But if it lives on our platform, we don't charge for it. And Zenko, as well as Scality Ring, is licensed by Data Managed, which is a unique thing. So if you look at it for like most platforms, I deploy 6 nodes, and that's a petabyte of raw disk. I need a petabyte of storage software to live on it. Even though 10% is for the OS, 20% is for metadata, and then the remainder is for the blob. If you've got 3 copies and you've got 300 terabytes, we say, even though it's a petabyte of disk, you have to give us a license for 300 terabytes because that's the data amount, not the capacity allocated. So therefore, this is kind of the cool thing with HPE is that since we have a really modular scale methodology between a connector, performance, capacity, we can add as small as 2 drives, is that if your policy is 3 copies, 4 copies, or whatever your policy is, you're not double or triple paying for our software. You get a petabyte of data, you have a petabyte license. If you want to store that on 4 petabytes of disk, that's up to you. That's your storage policy. So, which is very unique because most are, the box comes with a petabyte, you have a petabyte of licensing. And you guys probably been through this a million times, is that if you got billions of small files, the file's 4K, guess what? The metadata is 4K. And then you're gonna do protection on the metadata, you have 4 or 5 copies of the metadata. So that means a gig comes in, you're storing like 5 or 6 X's all overhead. And that's where like cost comes into it, is we don't charge you for those situations. We're just the data, right? So that's a huge one, yep.
You don't need to do like variable block sizing and all that kind of stuff, because it's block-based, it's object-based storage, right?
Right, yeah, so anything smaller than about 60K, we're not gonna recommend erasure coding. That will make replica, because basically your stripe size will be bigger. You're gonna have a lot of wasted space. So we would actually, and the system will do that automatically. But yeah, so if you've got a 40K or 30K file, we're just gonna default it to replica. But again, we're not gonna charge you for it on the software perspective. If that makes sense, right? Which I think is, I've been through a lot of those before, so they're not fun. Because if you think about it, like your customers are looking at like data size, like how big are the files. Like we were in a healthcare environment for PACS, and the study size, the customer thought they were megs. We got in, there were 8K. It was radiology, because some of the applications at Space now will take just everything but the bone and the break. Everything else is gone. Whereas before they used to store the whole thing. So they've optimized. These applications are really optimized, which then creates a storage problem, right? And some of the things that we do at storage, I think, are help in those types of situations, right? Is that nobody does a good job with small files. 1, we're stateless. 2, we'll default to whatever is the most efficient methodology. But again, as your licensing doesn't change.